Hello and welcome to this webinar from the ICA EGAT about the current state of the new records in context standard. This is a three-part webinar. My name is Tobias Wildi. I will do a short introduction into the current state of records in context and say something about the general design principles of records in context. In the second part, Bill Stockting, who is the manager of the Royal Archives, he will talk about the conceptual model of records in context. And in the third part, Florence Clavaud from the French National Archive is talking about RiC-O, the records in context ontology. And you already see here on this list, the new standard is made of 4 parts, 4 different documents, and I will talk about these documents in just a minute. Now, the new standard. Who is the author of the new standard? It's a group of 21 members from 14 different countries, all with very different backgrounds of different archival theories and archival traditions. The group is called Archives Expert Group on Archival Description and has a mandate from the International Council on Archives, the ICA, to develop this new standard. Now, something about the status quo of archival description. Where are we today? The content of archives is today described mainly in 3 standards: ISRG, ISDF, and ISRCPF. And most of you know the ISRG standard. It models the ISRG. It describes the content and the context at the same time of the archival material in a hierarchical manner. So you all know this structure, this hierarchical structure with fonds, with series, with dossier, with item, and so on. And we have exactly one hierarchy in ISRG, not more, not less, and thus we can call it a monohierarchical model of description. And at the bottom of this page, you see how the contextualization of archival material is thought in the existing standards. So we have ISRG, which describes the content of the records and the context. It gives information about title, date, so all the details around the records itself. And then we have ISRCPF, which describes corporate bodies, persons, and families. It's the who, it's the agents, it's the actors who interact with records and create them, change them, modify them, and so on and so forth. And as the third part in this triangle, we have ISDF, the standard for describing functions, business processes, and so on. And that's a standard to describe how has the work been done in an administration, for example, or in a creative process, and so on. And that's the general view on these 3 existing standards. Well, the problem is, in theory, this looks all very good and very reliable and so on, but we have some problems. The development of ISRG, ISOR, and ISDF were not really coordinated. They didn't happen at once as one coherent whole, but the 3 standards were developed one after the other and were not really coordinated. That's one problem. The other problem is, apart from ISRG and ISRCPF, perhaps, these standards, the other standard, ISDF, and there's even a 4th standard, they were not really taken up by the archives nor by the software vendors. So more or less, we are stuck at ISRG description in most of the archives. And the existing standards, they leave much room for interpretation. There is no technical implementation. And so this leads us to a situation where archives have archival information system, and they cannot change from one product to another because every software vendor has to interpret the standards on his own way. And so we currently have in a lot of archives a so-called vendor lock-in, where archives or institution cannot change their software for describing archive. One other thing that is problematic is that linking to external resources is very difficult. So, for example, if I have a record and I want to link to a book or a printed material in the library that is described in a library catalog, it's very hard to link, or in other words, it's not described in the existing standard how this linking out of the archival work could take place. And then, because we have a mono hierarchy in ICA, only one context of the records can be described, and if we have more contexts, if we have a richer provenance model that we want to encode in our archive, this is not possible with the current standard. Now, this leads us to some design consideration for records in contexts. What EGOT said at the beginning of the development of RiC, that the existing ICA standards, of course, they serve as a point of departure, but as I said, they are a bit outdated. Then we have current and emerging new technologies that present opportunities to re-envision description. And in particular, these new technologies are semantic and graph technologies, or in other words, linked data, where we go from hierarchies or relational databases to new data models, where data are modeled in networks or in graphs. This means that formal modeling techniques are very important. New formal modeling techniques came up in recent years because they provide means for logical rigor, and at the same time, also flexibility for network structures. So in the left schema, you see a hierarchy which you can very well model, for example, in an XML file. A tree which has a root and then goes further down into the branches and the leaves, and you can model, for example, as a G in XML very well. EAD, the encoded archival description, uses XML as an encoding modeling language. On the right, you see the new possibilities with network-based data modeling. Where we have again different entities, and we want to interconnect these entities, not only in a hierarchical manner, but also on vertical levels. We have a much richer model of interconnecting these different entities. And on the right, basically, that's the data model that we see, in which we see a great potential for future data modeling with the help of records in context. So another design consideration from completely other focus or point of view is that in recent years there were critiques and questions regarding the traditional understanding of the provenance model. What is a provenance? How to describe provenances? And is there really only one provenance, or could there be richer modeling or an more expansive understanding of context and provenance? And Bill will come to this later when he explains the conceptual model. And at the same time, there are ethical and intellectual questions and critiques regarding the role of records managers in formulating social hierarchy. The records managers, or people working in administrations, for example, they decide in a way what kind of records go into the official memory of an archive, and thus form the social memory of an archive or even of a society. And we all come to the conclusion nowadays that there are that there are different views on the same events, for example, and we need a standard that makes the encoding of the different views, even contradictory views on one event or a group of records or whatever, makes it possible. Now, just an overview of records in context. It's one coherent standard. It's only one standard, not three standards anymore. On the left, you see the record resources. That's the whole part where ICA was set in the existing standard as a standard word. Then on the right, we have the agents, which today is ICA or CPF, and on the bottom, the events and activities, which today is ISDF. So we still have this triangle, but it's much more elaborated. The relations are explained. It's very clear how to link from one standard or from one part to the other. I don't go deeper into this model. You will hear a lot about the model itself later on. Now, one design consideration that is really important is the link to other standards and material outside the archives. So linking to museum objects, for example, to printed material in libraries, to other resources must be possible. One critique that came up with the current version of records in context is that there is no logistics module, so there is no possibility to describe, for example, shelves and shelf space and boxes in the archive. And of course, we need this component, but we don't necessarily have to put it into records in context. We can very well have a logistics ontology or a logistic module outside of records in context, but we have to make sure on how to link records in context with this logistic module, or how to map archival description with library catalogs, for example. So we need an alignment with records management standards, with library, with museum standards, even with business processing models, with logistics standards, and so on and so forth. An alignment, not necessarily a mapping, but we need to define the interaction, the interfaces from one standard to the other. And then we see emerging local and national standards for different fields. Logistics I already mentioned, but also in the world of digital preservation, we have several standards that are really important to describe all aspects, all different aspects of digital objects that we want to preserve for the long run. One very important standard in this field is PREMIS. PREMIS is a metadata standard for technical and administrative metadata. So it's clearly complementary to records in context. Our standard describes the descriptive metadata, or encodes the descriptive metadata. PREMIS, on the other hand, the technical administrative aspect of digital object. And as a whole, we could form RiC and PREMIS a very coherent data model for managing digital objects. And in fact, in the last few weeks, we already had 2 meetings with the PREMIS editorial committee to discuss between EGAT and PREMIS how could we combine these two standards, these 2 different standards, to describe in the future digital objects. Now the different subparts of the records in context standards. First, we have an introduction to archival description. That's about a 5-page document, which starts with the history of record keeping and says something about the principle of provenance. Also, now the expansion of this principle. It says something about the role of the archivist and the role of record description. 3 that's three main roles. It's the management of the records, the preservation of records, and the ongoing use and reuse of records. And this introduction, it seemed to us as such an important part. We decided to make a known document out of it, just to put it at the beginning of the standard. Then the second document is the conceptual model, the RiC-CM. It's a high-level model that focuses on intellectually identifying and describing records. I don't talk more about that. And records in context ontology is a specific technical implementation of the conceptual model in the web ontology language, OWL, and RiC-O provides the archival community with the ability to make archival description available as linked data. And the beautiful thing about RiC-O is that we have a technical standard there that we can use to implement to encode metadata, and it doesn't. We're not dependent from one or another software product. We know whatever software product you choose, at the end you have standardized metadata in RiC-O, and it's a way to make us a bit less dependent from software vendors, and we can choose whatever product is appropriate for our archive. And the last part of the standards will be the application guidelines. We haven't yet started with the application guidelines because records in context is not yet on the version 1.0. So we wait a bit with this part, but we're also already collecting a lot of material from projects that are already using records in context, and we want to show how not only why, but also how records in context can be implemented, what could be a roadmap to implement the standard, what could be implementation strategies. And already a lot of archives and projects, they are now making their first steps into the records in context world, and we want to take their experience that they make and then formulate perhaps not yet best practices, but some first practices about how to implement records in context. So the development process as it is now in September of 2022. We made two phases of where we were looking for extensive public feedbacks. That was in 2016 with version 0.1, and then we have had huge changes from version 0.1 to the current version 0.2. Another feedback phase was done in 2021-22, and the changes from the second feedback phases will not be that big to the final version 0.1. But already at the moment with version 0.2, we consider RiC as stable enough that it can be used in projects, and the goal is to publish records in context 1.0 until the end of 2022, until the end of this year. Okay, this was my brief introduction. And now I want to hand over to Bill Stockting, who is going to explain you the conceptual model of records in context.
Thank you, Tobias. Today then, I'm going to talk to you about the second draft of the Records in Context Conceptual Model, RiC-CM, which is one of the 4 parts of the Record in Context standard as a whole. I'll start with some brief contextual background, looking at the nature of a conceptual model and its purposes and scope. I'll then take us on a whistle-stop tour of the conceptual model as it now appears in its second draft version. As this is an entity relationship model, I'll spend most time on the superstructure of the model, the entities, before looking at their characteristics, now called attributes rather than properties, and finally at relations between the entities. As I do so, I'll draw particular attention to significant changes from the first draft. I thought it would be useful to start by giving you some brief background to the conceptual model and underline what its purposes are and indeed what they are not. So what do we mean by conceptual model in this context then? Our area of interest, our discipline, is the intellectual description of records, which represent and are evidence of the complex affairs of human society over time. Given this, the model's purpose, simply put, is to represent this complexity in terms of its high-level concepts. In doing so, the methodology uses entity relationship modeling, ERM, the focus of which is to model things and the relationships between them, for representation in information systems. In RiC-CM then, we have defined the key things or entities necessary to effectively describe records for the purposes of those who preserve, manage and use them over time. That is, the records themselves, the people who create them and the activities they undertake when doing so. We've also defined, again with a focus on archival description, the significant characteristics or attributes of these entities, as well as the key relationships between them. RiC-CM then provides a generalized view of archival description. It should not be confused with the more detailed logical and physical data models necessary to build records management or public information systems, or the other tools used by archivists on a day-to-day basis. So RiC-CM is not a set of detailed cataloging guidelines or an XML schema for data exchange such as EAD or EAC-CPF. Rather, the conceptual model, alongside the ontology, provides the basis for the future amendment and development of such systems, cataloging guidelines and communication standards. Conversely, this does not mean that all existing archival cataloging information systems will somehow be instantly out of date when the model is published. The new standard is based on traditional principles, in particular that of provenance, and uses the current suite of ICA description standards, ICG and its siblings, as Tobias says, as a starting point. There is no expectation that everyone will suddenly be cataloguing new ways, and that would obviously be impractical. Rather, as a model suggests what should be described at a high level, not how actual descriptive metadata for archives should be captured or stored or formatted or presented in detail, most of what is done today will still conform to the model to a great extent. While the model must present the current professional consensus about archival description, our practice will continue to develop and change. So the first published version of it will not be set in stone. It should, though, help inform ongoing discussions about what we do when we intellectually describe records, and have a useful role in the education training of archivists at all stages of their career. It will also enable better collaboration with fellow information professionals, especially within records management, preservation and cultural heritage, who have already developed models specific to their particular activities and domains, and position us to ensure that the archives in RiC take their proper place in the digital world. Practically, it will do this, as Tobias has suggested, providing the basis to produce archival metadata in the form of linked open data, using the records in context of Ontology, RiC-O, which we'll hear more about from Florence later. The extensive feedback from the first draft has served as a basis for EGA's discussion since then. The result of this work is that the second draft exhibits some significant changes from the first. The introduction has been substantially revised to highlight the intellectual and technological contexts that account for the model's revised approach to archival description. The feedback suggested the model need to be clearer for those whose starting point is ICG. The entity section has been reorganized and restructured to emphasize the entities key to those managing records, while the sections on attributes and relations attempt to eliminate redundancy to enhance clarity and understanding. A key change throughout is that the model now clearly distinguishes the description of the intellectual content of a record from the physical representation of that content. As has been said, we are now analysing the great feedback to the second draft, and while there will be changes in version 1.0, we don't envisage they will affect the basic structure that I'm setting out here today. We'll begin then with a detailed look at the entities. which, as I've said, are the key things necessary to effectively describe records for the purpose of those who preserve, manage and use records over time. As can be seen from the table on the slide, in the second draft the entities are grouped in a 4-level hierarchy. At the root of the hierarchy, level 1, is a thing entity. This entity encompasses all possible things, be they concepts, material things or events. The entities explicitly included in the model, as can be seen set out in levels 2 to 4 in the table, are the ones of primary interest to those of us who manage records, providing the intellectual context to enable their physical management, preservation and discovery and use over time. There are the 4 key entities presented in bold on the table: the record resource and its instantiation, agent and activity. These are the entities considered essential when describing records and their contexts of their creation and use, representing as they do agents utilising recorded information to carry out their activities. The remaining entities in the model then are those considered necessary for the complete description of the core entities so that they can be fully understood. The addition of the root level thing entity means the model is extensible and allows the inclusion of all or any other contextual entities necessary to fully describe records in real-world implementations. Looking at the sub-entities at level 2, we begin then with the what. That is, the records and carriers that we need to describe. The first draft of the model moved on from ICA's singular unit of description by specifying that archival information objects do have very real differences, and these differences need to be reflected when they're being described. There were therefore the 3 entities record set, record and record component. While this is still the case, to recognise that these 3 types of information object are nonetheless still the same kind of thing, the record resource entity has been added as an overarching entity in the second draft. The record resource entity is then conceptually comparable to ICA's unit of description. Record resource has 3 sub-entities representing the objects we describe in practice: the record, its parts, called components in the first draft, and the set or sets in which they may be included. So we have the record itself, which, as expressed in ICA, for example, equates to the item level unit of description. Significantly, the definition makes it clear that, whatever other uses to which a record is put, it always documents or is evidence of the activity undertaken by an agent. And that to be a record, information must be ascribed at least once. In a sense then, whether digital or analog, it needs to take a physical form and must have at least one instantiation. Records, particularly those created and managed electronically perhaps, may themselves be made up of parts with discrete information content, without which the record may not be physically or intellectually complete. In many cases, it may be difficult or indeed unnecessary to describe the constituent parts of a record. In others, though, particularly with born digital records, it may well be necessary to meet the needs of those undertaking the description and enable ongoing preservation. Given this, one agent may describe a particular record resource as a record and another as a record part. As the purpose and functions of the agents may differ, though, the definition of a record resource as a record or record part is in itself a matter of perspective. Records, though, may be, and indeed often are, of course, included in groups or aggregations, brought together by an agent or agents based on some shared attribute or relation to serve some end of their own. As in the first draft, these groups are represented in the model by the record set entity. The record set is a kind of record resource then, but it differs from a record in important ways. We have, I think, often recognised this in practice, but is now made explicit in RiC-CM. The identity of a record is only dependent on itself, its constituent parts, while that for a record set is also dependent on and derived from the records making it up. Moreover, while a record must be inscribed at least once, this is not the case for record set, which, as it is based on some shared attributes or relations, is an intellectual aggregation. A record set, though, may be inscribed physically, such as when digital copies of records are gathered into an online blog or learning resource, but this is not necessarily the case. A record set may be a series of records brought together in the course of documenting a particular activity. As a record set can also hold other record sets arranged hierarchically. That series may be one of many grouped in a superset based on provenance. The records of a particular creator, a font, if you like. The model then allows traditional multi-level description at font or indeed at series level. It also, though, allows records to be seen within other groups. Many of us have collections of material that were brought together by us based on criteria such as record type, topic, or place, rather than in provenance, for example. RiC-CM allows such descriptions to be described as such. Now, though, records are created in electronic environments, where they may be arranged and rearranged to suit the needs of their creators over time. Users of archives also group records in ways which suit them and their interests, their contexts. The point being that a record at any point in time may belong to many groups, not simply those defined by a single hierarchical arrangement. And modelling records, their constituent parts and record sets as separate kinds of record resource allows a description of the complexity in which records are created, maintained and used over time. The feedback to the first draft confirmed something for EGAD of which we were aware: the lack of distinction and therefore clarity between the intellectual and the physical characteristics of records. In the second draft, the record resource entity then relates to the intellectual content alone, the message itself. A new entity, instantiation, has been introduced to allow description of the physical form of the carrier on which a message is represented. This then allows for the management and preservation of not only the record resource over time, but of its representation or representations. It is no surprise, therefore, that this distinction in RiC-CM is comparable to that found with the object entities, intellectual entity, and representation in premise, for example. We have said that a record must have at least one instantiation. Our experience, though, tells us that a record may have multiple instantiations at the same time and or over time. Paper and parchment records are copied, perhaps in writing or TypeScript, or indeed now in digital formats. On digital records are often copied many times, of course, by their creators and then by others over time, particularly perhaps those attempting to preserve them in the long term. It follows that an instantiation may be derived from another instantiation, and indeed that the original instantiation may well not survive. This is explicit, of course, in the use of migration strategies within digital preservation programs. Whether a later instantiation is considered to be the same record or a new record will depend on the context in which it is created by an agent. The characteristics of the new instantiation may lose or alter those in the original, of course. And so this again is then a matter of perspective. The model gives the example of a map that is digitized as a PDF file. The file may be seen as an adequate instantiation by a researcher interested in the place as represented at the time of the original map was created, but not by the researcher interested in the materiality of the carrier. We then move to the who, that is, the agents that undertake the activities that generate and manage records. Like record resource, the agent entity is a second level core entity in the model. The entity has 4 sub-entities. There are individual persons and groups. The group entity has 2 sub-entities, corporate body and family. Other groups are of course possible. The hierarchy in the second draft of the model again allowing for extensibility. In a change from the first draft, the position entity is now a sub-entity of agent and is defined as the functional role of a person within a group. As such, the role a person has is distinguished from the individual that holds it, and if so described, users will be able to navigate to the records of particular individuals holding the same roles over time. Finally, the delegate agent of the first draft has become the mechanism sub-entity. That is, a process or system such as software, robots or probes created by a person or group that performs an activity. We then have the entities that model the why and the how agents create records. Here in the second draft, the core entity is known as activity and is a sub-entity of the first level event entity. This entity, the event entity, relates to anything that happens in time or space and may be natural or involve human agents. Events, especially of complexity happening over time, will have sub-events, such as the skirmishes within a battle that itself is a sub-event of a war. Activity then is seen as a kind of event carried out by agents that has an intended purpose. In RiC-CM, the scope of activity of corporate bodies is the same as the traditional understanding of function, as seen, for example, in the current ICA standard for describing functions, ISDAF. The name activity, though, is given to this entity, as while it is appropriate to describe corporate bodies' position and mechanisms, functionally it is less appropriate for the activities of persons and families. Moving on from the core entities, we have the rule entity. Rules are defined as conditions that govern the activities of agents. They affect and perhaps specify the essential characteristics of things produced by such activity, as well as how those things are managed over time. When acting, a governing condition for the agent is that they have the authority to do so. The authority may be implicit, such as social customs or expectations, or in the case of a creative person. It will often, though, be explicit, especially in the case of complex bureaucratic activities, and be expressed in documents such as laws, regulations and standards, which mandate the agent to act and specify how they should do so. In the second draft of RiC-CM, then, the mandate entry is seen as a kind of rule. A mandate is the delegation by an agent to another agent of the authority to perform an activity. It's important to note that rules and mandates are in themselves intangible and should not be confused with the documents, the records, which provide evidence of them. Examples of this are clear, of course, in our own professional practice. Records managers and archivists have authority to manage, preserve and provide access to records. How we do this is also governed by rules of privacy governing access to records and of intellectual property governing how they may be used. RiC-CM is, of course, part of a rule set specifying how we describe record resources. The final two level 1 entities in the model are date and place. All things exist in time and space, and describing where an entity is so situated is critical to providing the context necessary to understand the entity. Date, with its sub-entities, enables a description of the temporal context of entities, such as when records were created or undergo preservation activities, or the birth of a person, or when a corporate body or position come into being, or the periods of time when mandates are in existence and activities take place. While place, defined as a bounded geographical area or region, enables description of the spatial context of entities, places that are the subject of records and where they are held, or where a person was born, lived, worked and died, or the jurisdiction to which a mandate applies, thereby constraining the activity it authorises. We now move on to the attributes. That is, the characteristics of our entities which, with any relations between those entities, constitute their overall nature. In the second draft we have two sections. The first lists the attributes alphabetically and provides a detailed description of each in a standard template, as seen here on the slide, for the accrual attribute. In the second draft there are notes on whether an attribute is repeatable, the application value schema from a set of 4 increasingly constrained formats, and whether it is extensible by the addition of other attributes in real implementations. The second section provides lists of the attributes for each entity. I obviously can't go through them here in great detail, but I'll try to give an overall view. It will be seen that these attributes, that there are attributes in common across the entities, and many of the attributes will be familiar from the elements found in the current ICA descriptive standards. It should also be noted that as the entities are now in the 4-level hierarchy, the attributes of each superior entity are shared by its sub-entities. The attributes for thing are shared by all of the entities in the model then, while those for record resource are shared by record set, record and record part. The attributes of thing are those providing key identification for the entity, an identifier, a name as well as a descriptive note. Given that we now have a separate instantiation entity for description of the carrier, the description of record resource focuses on the intellectual, the information itself, as I've said. Aside from the attributes shared with thing, the record resource entity has attributes describe its extent, arrangement, here given as structure, scope and content, and history. The record and record part entities again share these attributes and also have the same set of familiar attributes that break down into those describing the content of the record, its type, that is a basic form such as text or still image, its specific documentary form type, which was an entity in the first draft of the model, its authenticity and integrity, and the language and scripts in which it is written. And those attributes relating to the management and use of the record, how it may have been classified, its legal status, its conditions of access and use, and its state as a draft or a copy perhaps. The recognition that a record and a record set are different kinds of record resource has implications for the attributes given in the model and how they are used when we are trying to make it clear whether an attribute describes a record set itself, some or all of its member records, or indeed both. The latter, that is the description of both these contexts, applies to two of the attributes shared with the record resource entity, history and scope and content. Aside from the shared attributes, there are two attributes, a description of which relates only to the record set itself, accrual and record set type. This, of course, is equivalent to the level of description element in ICA, so it could be set at font or series or file, but perhaps also at collection, for example. And these are not found, therefore, as attributes for record. The remaining attributes for the record set, most of them, which are also found for record, may be used to describe all or some of the records within the record set, rather than the record set itself. How this happens in practice, of course, will depend on the nature of a particular record set, of records one is faced with. We have said that the instantiation entity represents the physical way in which the information found in a record is represented. As such, it has some attributes that are also found for record, but relate to the particular representation. It is then possible to describe an instantiation's history and structure, authenticity and integrity, and any specific conditions for its access and use. Other attributes relate to the nature of instantiations alone, and provide description often necessary to preserve and manage them, such as notes about physical features, the method used to represent the information on the instantiation, how it is recorded, and any issues with the quality of that representation. The carrier type, that is the form of material from which it is made, and the carrier's extent. And the latter is not to be confused with the extent of the instantiation itself. A Word document of 200 kilobytes might be found, for example, on a CD with a carrier extent of 700 megabytes. Aside from the attributes shared with the thing entity, the agent entity has those for the history of the agent, the languages they use, and their legal status. These are shared by the sub-entities, and those other than position have some specific attributes of their own. Person and group have the demographic group attribute, which replaces the gender property in the first draft. Family and corporate body have a specific type attribute, while person has an occupation attribute, occupation being an entity in the first draft. Mechanism has technical characteristics attribute, allowing for a fuller description of its features, particularly as they relate to the creation and use of records. The event and rules entities, and therefore their activity and mandate sub-entities, have the history attribute, while event and activity also have specific type attributes. The event entity, along with the date entities, also has a certainty attribute. The date entities also have the date qualifier attribute to indicate the precision of a date, and attributes to enable the capture of normalized versions of the date for machine matching and processing. Finally, the place entity has a history attribute and a specific type attribute, as well as attributes to allow the definition of the territory covered by a place as a text-based location, such as an address, as well as precise geographic coordinates. Finally, then, we come to the relations. And relations in RiC-CM describe the connections between the entities as they contribute to the context of record making and keeping. Taking account of the feedback from the first draft, extensive changes were made in the second draft in this area. The relations section being both more focused and more structured. There are now 78 relations in all of which have inverse relations. So, for example, has provenance, has the inverse relation, is provenance of. In some cases, though, relations are symmetric, such as is associated with. The set of relations, though, is not exhaustive, and the focus is on those reflecting the who and when and where of the creation, transmission, management, and use of records, their parts, and aggregations. In this context, too, the model is extensible, and when implementing more specific vocabularies can be used to build on the foundation of the model. To clarify the role of a relation when describing records, all relations fit into one or more of 13 conceptual categories. Whole-part relations between a record and its parts, for example, as well as sequential relations where an agent has a successor agent or an original record has a draft. There are relations between a record resource and its subjects or topics. Relations between record resources and between them and their instantiations, which of course also have relations between each other. There are provenance relations, of course, key for archival description of record resources and instantiations with agents. And there are relations between agents alongside those with entities they may have authority over, and finally the key relations between the event, rule, date, place, entities and other entities. Like terms in many controlled vocabularies, the relations also range from broader to narrower in a 6-level hierarchy. The broadest and only relation at level 1 is a thing is related to thing. And as one moves down the hierarchy, the relations get more specific. The level 2 provenance relation, has provenance, encompasses the relations has creator, has accumulator, and has sender at level 3, where greater specificity of the relation between an agent and a record resource is known or desirable. It should also be noted that the structure is polyhierarchical, meaning that some relations appear in more than one category and or level. Finally, to allow for cases where a simple connection between the two entities does not provide all the information necessary when describing a relation, the model defines a set of attributes specific to relations. They include the ability to add a specific identifier, which may be local or globally persistent, a date or date range when the relation occurred, a level of certainty about the relation, the source of information for a relation, and any other description about the relation thought necessary. Now, you've seen this diagram before. My presentation really has rather atomized the standard in order to describe its parts. It's important, though, to conceive these parts as a whole. This can be seen here in this idealized example, where we have the 4 core entities with the key relationships for archival description represented. Record resources, with the attributes set out earlier, may have an instantiation with its attributes. Records and instantiations have as provenance an agent, but be that an individual, group, or indeed machine. Records document the activity performed by the agent, and in this example also shows the mandate, which may regulate both the agent and the activity they undertake. This is then a good place to stop, as I'll now pass you on to Florence, who will look at the records in context ontology, RiC-O, in detail and show some real-world examples. For those of you attending the ICA conference in Rome, remember too that there will be a session on real-world implementation and a workshop. Thank you.
Good day, I'm Florence Clavaud. I work in the Archives nationales of France, and I'm a member of ICA EGAD and lead of RiC-O development team. And as Bill said, I will present an overview of records in context ontology and some examples. The first thing to say is that RiC-O is the third part of records in context standard, which, as you know, has 4 parts. You have the introduction to archival description, the conceptual model, on which Bill presented, and the application guidelines, which will be released in 2023, and the ontology, on which I will talk now. The current version of the ontology is 0.2 version, just as for RiC-CM, and it was released in February 2021. Some key information in order to begin about RiC ontology, which I will call RiC-O further. It's a technical transposition of the conceptual model, and it has become the first comprehensive technical ontology and domain specific, since it's about describing archives and archival material existing in the world. When we began to develop RiC-O, we found that there was no other ontology of the kind that is represents the world of archival material from an archival perspective in an accurate way, and so we decided to develop an ontology along with the conceptual model, and it aims to be the reference formal model for publishing high-quality RDF graphs describing archival material into the world of linked open data or semantic web. The latest version of RiC-O, so for now RiC-O 0.2, is always accessible to humans and to machines through its identifier, which is the following. It's of course as a form of a URL. And when you are a human being and use a web browser and type this URL here, you will access the a web page which I've displayed on to the right of the slide, which in fact displays the textual documentation of the ontology, everything that is edited in it. The ontology being in fact a much more technical file. It's a RWL conforming file that you can download when you click on the link here, and which you can also download from the public repository on GitHub that was released in March 2020, where you can also find a lot of diagrams and examples of RiC-O files, RiC, describing archival material using RiC-O. Everything in this GitHub repository is under CC BY 4.0 license, which means that you can use it really freely. And of course, as it is a repository on GitHub and a Git project, you can duplicate the repository, create issues on it, comment the issues, and basically participate to the development of the ontology. The GitHub repository comes with a small information website where you can find other details about RiC-O. For example, a page which gives an idea of why using RiC-O, a page that lists projects and tools about using RiC-O, or tools for example, to generate or query RiC-O sets. And you also have a discussion list, and information about this list is in this website. So, but if you want to keep up to date with what is going on about RiC-O, you just have to look at this website or subscribe to the discussion list. Now, let us go into more detail. What are the main characteristics of this ontology? First, the first thing we can say is that it already has a quite long history, since the first versions were developed in 2017, and some beta versions, which means beta versions that can be shared and already extensively tested, preliminary versions of an official version, were released in 2019 and sent to early reviewers which had volunteered to test it and have a look at it. The 0.1 version of RiC-O, the first official version, was released in December 2019, and the ontology continued to evolve towards this 0.2 current version. In fact, the ontology was developed side by side or along with the model, the conceptual model, and it played a major role in testing it, and also in help to have ideas to complete the model and to find good solutions for formal representation of some entities or attributes or relations. This is the first characteristic. The second one is it's really is a fully compliant technical representation and fully compliant with the 0.2 version of the conceptual model, which means that all the entities, attributes, and relations that are defined in the conceptual model are also defined in the ontology. And we have details about this in a few minutes, and also much more, because a technical implementation of a conceptual abstract model is necessarily more detailed. And so you have more components in RiC-O than in RiC-CM. Another reason for having a richer ontology is that RiC-O has been designed to be immediately usable and very flexible. I explain this also in a few minutes. Another characteristic is that it is fully documented already, only in English, however, and it comes with a quite long introduction that includes details on the design principles and also on how you can, when you know RiC-CM, you can understand RiC-O, what the path is from the model to the ontology, and a complete list of changes that were made in the ontology since 2019. Each of the components of the ontology is defined with using the formal possibilities that OWL offers, and also using textual annotation, for example, a definition, a scope note, or examples. And we also created a specific annotation property that helps to map RiC-O to RiC-CM in order to specify for each component of RiC-O when it is compliant with RiC-CM component, what is this component. one of the main design principles of the ontology is that it has been developed in order to be immediately usable. It was a key feature for us that it can be used really just now to accommodate existing descriptive metadata. And of course, also at the same time, to be able to represent in an optimal way data based on the conceptual model. We know that today in archival institutions or within projects like aggregators that use archival metadata, the models that were adopted are ICA, RiC-CM, and often their XML corresponding formats, EAD and EAC, namely. And these formats and former standards by ICA are quite far from the conceptual model and ontology. But we wanted the ontology to be usable really immediately. And so this explains that often the ontology provides with more than one method for representing a statement or a feature of an archival resource or a contextual entity of an archival resource. Another very key feature of archival description is that it is by essence flexible, which means that depending on the means you have, the time, the knowledge you have on the resources you are describing, you will be able to describe it really accurately, or to provide much more vague information. You will also decide that you will describe archival resource at a high level, for example, a fonts or a series, or to go into much more details, for example, describe files and items. And in the same finding aid, you can find both kinds of metadata, and RiC-O has to accommodate these. And so you have really this feature of archival description implies that in the technical ontology model, you can have quite broad upper level entities, classes, and properties, and have also much more detailed ways of describing being subclasses, subproperties, or other more complex semantic blocks. This is one of the main things you have to have in mind when you go and look at RiC-O. To be more precise, I said a few minutes ago that every RiC-CM entity is represented in RiC-O. This is a simple, very simple thing to understand. Each CM entity is available in RiC-O as a class. An entity is a category, a class is a category of objects. And so, for example, I have on the slide here, you have to the left the description of the RiC class in RiC-O. You can see that it is mapped to RiC-CM RiC entity. It's just the same. In fact, it has the same label, the same name, the same definition, the same scope note. It's also defined as being a subclass of RiC-O record resource class, just as in RiC-CM, record is defined as a subcategory of the record resource entity. So it's just quite easy to draw a line between RiC-CM entities and RiC-O classes. To the right, you have an overview of the hierarchy of classes in the ontology, where you can see that you find the classes that correspond to RiC-CM to the 22 RiC-CM entities, for example, here the thing, which is the upper level class in RiC-O, just as in RiC-CM. Agent, then group, which is a subclass of agent, corporate body, subclass of group, etc., etc. And you also can see that you have other classes as the entities defined in RiC-CM, for example, concepts or coordinates or extent, physical location, and relation. In fact, there are many other classes in RiC-O as there are entities in RiC-CM, just because we need some more accurate and structured model in the ontology. Now, as concerns the attributes of RiC-CM, which is the inherent characteristics of the entities, basically you have two kinds of possibilities, which implies that I explain first what is a property in an ontology. In an ontology, you have classes and properties. Properties are verbs in triples. A triple, an RDF triple, is a three-component phrase that is composed of a subject, a verb, and an object. Verb is also called a predicate. And properties in an ontology are verbs in triples. And you have two kinds of properties. You have the data type properties. These properties are defined as having as an object textual values. And you have object properties whose object, the verb has object, an entity. So when you come to RiC-CM attributes, the way they are represented in RiC-O depends on the value they can have. If the attribute has textual value, not a controlled one, in the ontology, it is represented as a data type property, a verb that has value, that has a textual value as object. For example, here on the left, you have the history data type property in RiC-O that is mapped to the history attribute in RiC-CM. History attribute as value some free text where you can type a narrative, a prose text about the history of the entity you describe. And so in the ontology, it's really logic, natural, normal that it is represented by this kind of property, data type properties. So any attribute that has a textual free value in the conceptual model, you have a data type property in RiC-O. And now in CM attributes, you have attributes that have controlled value. For example, documentary form type attributes, and which can be populated with values taken in a vocabulary. And so for these kind of attributes, the RiC-O uses classes for representing them. And so here you have a documentary form type class that is mapped to documentary form type attribute in the model. It just has the same definition, the same scope note, and can be used for record and record part just as for the CM attribute. And as it is a class, it needs properties in order to connect the record and record part to this class. So here you have has documentary form type or is documentary form type of property, object property that can be used to connect a record as defined in RiC-O to a documentary form type as defined in RiC-O. This is why in RiC-O you have much more object properties than in RiC-CM for relations. The RiC-CM relations, as a reminder, there are 78 relations defined in RiC-CM with their inverse ones. These relations become object properties in RiC-O. let me remind that an object property in an ontology is a verb that can connect two entities. In the triple, the object would be an entity. So it's really normal also that for each CM relation that connects two entities in the model, conceptual model, you have object properties, verb, that can connect two instances of a RiC-O class if you use RiC-O. Here you have an example. You have the has provenance object property, which is mapped to the has provenance relation in RiC-CM, and which can connect instantiation or record resources to agents. To the right, you have an overview of the hierarchy of properties in RiC-O, and where you can find has provenance, which has sub-properties, just as in RiC-CM has provenance relation as sub-relations. It's just the same hierarchy with other object properties also. A specific case in RiC-O is the relation class hierarchy. Let me try to explain. You may need to, as RiC-CM says, to assign dates, description, certainty, or source to a relation. That's why in the conceptual model you have attributes for relations. And in order to represent this kind of description in using RiC-O, you need to define class relations. You have an example here. You have a person, Jean-Noël Jeannonnet. He is a French person who led the Radio France, which is a broadcast radio company, public agency, and Jean-Noël Jeannonnet led this corporate body. So you have a person, you have a corporate body. This is an instance of RiC-O person and an instance of RiC-O corporate body, and a direct relation between these two instances, which is has or had leader, and his or was leader of in the two directions. If you want to say that Jean-Noël Jeannonnet was the leader of Radio France from 1982 to 1986, and this is a certain relation, you have to use an instance of the leadership relation in RiC-O. This is another object here, which is connected to the two former ones using other relations defined in RiC-O, object properties. And in RiC-O, this direct relation is defined as being formally a shortcut from this complex path. So you can infer this relation from this property path. This is what an ontology allows to do. And it allows to say that this relation has this date, this certainty, and this description. It's not in the diagram, but you can add attributes to this and also link this relation to, for example, a position that Jean-Noël Jeannonnet occupied as a leader. He was in fact the president of Radio France. He could have been the director, or I don't know, président, directeur général, as we say in French. But here you have what we call an n-ary relation. It connects 1, 2, 3 entities, can maybe connect other entities. So it's a way to represent relations in more complex, with a more complex structure. And this is why in the ontology you have a hierarchy of relation classes. For example, here, family relation, temporal relation between agents, or provenance relation, etc. Well, this was quite a short overview. Now, let me go to a few examples. The first slides have been prepared by Tobias Wildi and are about a photograph which represents a haystack, which results from a traditional activity in Switzerland, which is Wildheimaken, and which was taken in 1954. So here you have obviously a record. This is the photo itself. It's a RiC-O record, which has a date. RiC-CM provides an entity, date entity, which is represented by a date in RiC-O. This is a date, the date of the photograph. And it has an author, which is the photograph himself. And it represents a farmer whose name we don't have. And it documents an activity. And so this is how RiC-O would represent this record and its contextual entities. The next slides shows that from this conceptual, this intellectual object, there exists 4 instantiations, in fact, 4 physical materializations. You have the negative, the first one, the first instantiation, from which a contact copy has been derived, from which a TIFF image has been derived through a digitization program, and from this TIFF image, a JPEG web image has been derived. So you have 4 instantiations of this record connected to the record with the has instantiation relation, and these 2 instantiations are related to each other, and these two ones just the same. And this TIFF image is documented by its production technique here, while this one has another production technique type. Everything can be represented using RiC-O. Another perspective on the photograph is an archival perspective. When you can see that this photograph has been described as it is a part of a font, which is a record set. It was, this font has been affected by an archival description activity, which was performed by the City Archive of Baden in Switzerland, and according to some rules that the City Archive issued. And this activity, of course, has a date. And finally, this is another perspective using an event-based model that RiC-O can enable us to represent. This is the series, the sequence of activities or events that resulted in the photograph, which was described through the former slides. You have the author of the photograph, who decided to take vacations, then to take the train to the mountains, to check in at a hotel, to take a hike, and then to take a photograph. This is the series of events or activities that resulted in this archival resource. I have a few other examples in the presentation taken from our data sets in the French National Archives, our work. This is a graph that represents a company which produced a lot of aerial photographs during the 20th century in France. This is this company. This is its name. This is its legal status, and it's the font that it produced. And in this font, you have several albums, which includes groups of photographs arranged by the place they represent. Back to the corporate body, it is described using authority record, which is in French, which is managed by the Archive Nationale of France, which is regulated by some French standard, etc. Okay, I think I'm a bit too long in my presentation. So this is a very quick information of this diagram. It represents the font that the company produced, and this aggregation of record set. The font itself, a record set, includes about 100 albums, and each album includes several groups of photographs, and each group of photographs includes records. The group of photographs are subject a place, and an album usually has subject a larger district where the former place is contained. And well, I'll go further. This is basically quite the same view on one of the aerial photograph of the font as for the photograph on the haystack, with its different instantiation and the digitization event that resulted in the second instantiation here. So I won't be more long here. This is a view on the documentary font type of this record. It is a photograph. And the photograph is defined as being an instance of COS concepts, COS being a model for representing in RDF vocabularies. And it's also an instance of the documentary font type class, which enables in a RiC-O dataset to use a vocabulary represented in COS. It's quite really, it's an important feature in RiC-O. This is a representation of a place. It's more detailed than what RiC-CM provides for describing a place. This is a place. It has a physical location that can be connected to one-to-many coordinates. This is an instance of a coordinate class with a latitude, longitude, and geodesic system. Another representation of the coordinates, another set of coordinates, another object, which is a polygonal coordinates. And you also have in the diagram a very important oration category here, which is defined in the OWL standard, that allows to say that this place defined in the Archive Nationale of France is the same as this place as defined in GeoNames word database, as this place as defined in another French database, etc., which allows to say that all the properties, the attributes that characterize these entities in these external datasets can apply to this and vice versa. Well, back to the main slides. RiC-O is already in its current state a rich, consistent, and ready-to-use ontology, and is used in various projects, from proofs of concept to large-scale implementation. Here you have in this list, let me quote MemoBase, and also a project we are now working on in the Archive Nationale of France, that will be presented during the RiC applied session in the ICA conference in Rome, and other projects. You can see this page to have more details on this. This is another topic, but let me try to say a few words on this slide. It helps to understand that RiC-O can be combined with other ontologies, one being the premise, which is an ontology for preservation metadata, mainly for digital records. And so you can see that this class, this one, for example, are kind of hooks to connect the two ontologies, because RiC-O instantiation and premise representation are quite close and maybe defined as equivalent classes when we map RiC-CM and RiC-O to premise, as I think Tobias or Bill already said. We are working on with the premise editorial committee to try to articulate the two ontologies, which will allow to say that a RiC-O instantiation or premise representation includes files that can be described using this premise-based data. So it's important that the two ontology can be used together. I won't say, I don't have enough time to explain this, but and this is a screenshot from the project we are presenting in the RiC applied session, so I won't be long on this either. Just as a conclusion, here are a few details about the roadmap for RiC-O. We will try to map RiC-O with premise, as I already said, but also schema.org and Provo for before releasing RiC-O 1.0. We also, of course, have to take into account the comments on RiC-CM 0.2 and the changes that will be done in RiC-CM 0.2 so that RiC-O 1.0 is compliant with RiC-CM 1.0. We will probably split the ontology into several files so that it is easier to use, and try to start documenting RiC-O in Spanish and in French as it in English for now. And after RiC-O 1.0, the ontology will continue to evolve. We expect that the feedback and analysis of the practice will make it possible to identify the components of RiC-O that are the most frequently used, and maybe some that are not used and can be deprecated, or some needs that are not addressed well and that have to be addressed. And we will use, of course, this feedback to enrich the RiC application guidelines. As a conclusion, do not hesitate to contact us for any questions, suggestion, comment. You can simply send an email to me or to IGAD. You can also use the GitHub repository of RiC-O, as I already said. And we also would like to begin to think of building vocabularies, international vocabularies, for example, for documentary font types or activity types, in order to provide the archival community with common shared description of all these categories and use them with RiC-O. It would enhance their dev datasets conforming with RiC-O and help to connect them to each other. This is also reference to an article Tobias and I published last year about RiC-O. And I just want to thank you, finally. Thank you very much for your attention.